Okay, picture this for a second. You're on a survey ship. The deck is literally vibrating right under your boots, the clock is ticking on some seriously expensive vessel time, and you've just been handed a critical, high-stakes task. You need to commission an IX-Blue or X-Sail inertial navigation system and link a ROVINS or FINS unit directly into Eiva NaviSuite. The entire AUV integration depends entirely on getting this data link absolutely perfect. This explainer is going to be your essential field armor. We're going to lock down the exact standard operating procedure to bulletproof this data link so you can confidently report the win.
So here is our roadmap for the setup. 1. Architecture and sensors. 2. Physical interfaces. 3. 2 message paths. 4. The mirror config. 5. The diagnostic defense. And 6. The field checklist.
All right, kicking things off with Section 1, Architecture and Sensors, the foundation. First up, you really have to know exactly where your INS sits in the grand scheme of the vessel's architecture. It's essentially bridging two completely distinct zones, your surface support vessel and the submerged AUV. Now, the INS is the brain of the vehicle, sure, but it desperately needs aiding data from the surface and its local sensors to keep its inertial drift in check. Think of it like a giant puzzle where every piece bounds a different part of the drift. The DVL, that locks down your horizontal velocity drift. USBL or LBL acoustic telemetry gives you that absolute position. Your depth sensor handles the vertical channel, and the CTD or SVP manages acoustic range conversions. Finally, you've got GNSS and PPS handling absolute position and time sync when the vehicle is on the surface. But listen closely, because this is a massive field trap. DVL calibration is absolutely mandatory. You cannot skip it. Doing a scale factor and misalignment calibration between the DVL velocity frame and the INS body frame is 100% required before you can trust the DVL aiding. It's basically the underwater equivalent of a multi-beam patch test. If you skip it, your mission-grade navigation is pretty much garbage.
Moving right along to Section 2, Physical Interfaces, what you must recognize.
If you look at the central connector on a ROVINS or FINS unit, it is a beast. We are usually talking about a 19-pin plug that combines power, Ethernet, PPS, and serial repeaters all into one subsea package. So here's a golden training rule for you. Do not trust the physical cables alone. Serial ports on these units are configured for RS-232 or RS-422 entirely in the software. They are not fixed by the physical hardware pins. If you mismatch the setting, you're going to get garbled data or no data at all, even if your physical wiring is an absolute work of art. Never ever start troubleshooting your cables before you've checked the web GUI to confirm the port's electrical standard.
Okay, Section 3, 2 message paths, input versus output.
You know how a toxic boss sends mixed signals? Well, the INS hardware kind of does the same thing. It demands entirely distinct protocols for incoming versus outgoing data. You absolutely cannot assume the same telegram works both ways. The input to the INS, like your raw USBL position fixes coming from the top side, that has to come in as a specific proprietary format like $PUSBA. But on the flip side, the output from the INS, the final calculated navigation solution, that flows out in standardized formats like HS paused for position and HS tit for attitude, which covers heading, roll, and pitch. Basically, input and output are speaking two completely different languages.
That brings us to Section 4, the mirror config, NP config versus INS web GUI.
Managing these two separate interfaces is exactly where the most common commissioning faults happen. They have to be perfect mirror images of each other. You've got Eiva's npconfig driver topside and the INS web GUI subsea. If npconfig is set up for, say, COM6 at a baud rate of 192.008 data bits, no parity, and 1 stop bit, then the corresponding port on the INS web GUI, let's call it port B, must be set identically. There is zero auto-negotiation happening here. None. If npconfig expects to receive HSPOS and HSATEAT, the INS must be explicitly told to output them. Honestly, the #1 integration fault in the field is having both sides configured correctly in isolation, but disagreeing with each other. A topside driver shouting at 1920 baud to a subsea port that's still listening at its factory default of 9600, that's just going to give you dead silence.
And hey, if you are using network interfacing instead of a serial connection, the exact same mirroring logic applies to UDP/IP mode. Both endpoints have to agree. A super common network setup uses two distinct port numbers on the exact same IP address. For instance, npconfig might use a target port of 8203 to send the $PUSPA aiding data down to the INS, while it uses a listen port of 8204 to catch the HSPOS and HSAT nav solutions coming back up. We see UDP used constantly here because it completely bypasses that client-server handshake negotiation you'd need with TCP.
All right, Section 5, the diagnostic defense.
So what happens when you've set this all up perfectly, you hit go, and the Eiva IO status just blinks no data? Well, you need a strict structured defense. Here is your 5-step diagnostic order. Memorize it and do not let anyone rush you through it. Step 1. Verify the physical connection and the port identity. Are you actually plugged into port B? Step 2. Match the RS-232 versus RS-422 settings in the INS software. Step 3. Verify the baud rate matches digit for digit on both ends. Step 4. Ensure the message format the INS is outputting exactly matches what the NBconfig driver expects to decode. And Step 5. If you're on a network, confirm those IP addresses, port numbers, and make sure your TCV versus UDP mode matches on both ends. Just run this list methodically. It's going to resolve the communication fault 99% of the time.
Finally, Section 6, the field checklist and the win.
To make sure you never even have to use that diagnostic defense, here is your definitive 7-step field checklist for a flawless commissioning. 1. Verify your 19-pin physical connections. 2. Confirm the electrical standard in the GUI. 3. Sync up those baud rates. 4. Configure the INS to accept PUSPA input. 5. Enable the HS pause and HS attitude outgoing telegrams at the correct frequency, which is usually 10 Hz. 6. Map all of these settings identically into Eiva's npconfig interface. And 7. Pop open the NaviPack IO status and watch that glorious, clean data start rolling in.
So I want to leave you with this final thought. Your physical connections are verified. Your npconfig is perfectly mirrored. Your link is live and your data is clean. Trust your technical checklist.